Hello everyone, hope everybody's doing well. So we're going to talk about experiment 1, how to do the post-lab calculations. So I explained you in our pre-lab calculations the purpose of this experiment and what we are going to do. So basically we have this reaction iodide bromate in the presence of acid. We are making iodine, bromide and water. And we talk about this is a clock reaction where iodide that is generated first going to react with sodium thiosulfate, and then once all the thiosulfate ions have been used up, the iodine that is generated is going to react with starch to give you a blue color. So what we're going to do is we're going to time and see what is the time it takes for the color to appear as blue. So that gives us the time, and then the time is related to the relative rate of the reaction. Okay, and we also talk about in the pre-lab calculation part that you're going to be using two flasks, right? So also please watch the virtual video, it will explain you what we're going to be doing. So you're going to be taking two flasks, and for the first flask you're going to be adding these three reagents: potassium iodide, sodium thiosulfate and water in these amounts, 10, 10 and 10. And in the second flask you're going to be adding potassium bromate and hydrochloric acid together, and also to this you're going to be adding starch. And then you mix the two together. As soon as you mix, you start timing to find out what is the time it takes for the color to appear. And you can also see that we are changing the reagent amounts. So the first one, for the first reaction mixture, we have 10 milliliters Ki, and then the second one we have 20. And then the third and the fourth, we're going to be using 10 and 10. So sodium thiosulfate, we're going to keep it constant because it does not involve in our reaction to find out the reaction order. So we use sodium thiosulfate to introduce a clock to our reaction. Okay, and then we also use water to keep the volume of the final reaction mixture constant. Everything will be at 50 milliliters when we mix the two contents in the flasks. Okay, and then the potassium bromate, also you can see the amounts, and the hydrochloric acid. So our goal for this reaction is to find out what are the orders of the reaction. So the order could be a zeroth order, first order or the second order. For a zero order reaction, no matter how much you change the concentration of a particular reaction, the reaction rate will not change. First order would be if you double the amount of a reactant, so then the rate will also double. And then the second order reaction, if you double the rate of if you double the amount of the reactant, the rate of the reaction would be quadrupled. So we are trying to find out what is the orders of iodide, bromate and hydrochloric acid in this reaction. Okay, and then the orders are going to be different than the stoichiometric ratios. So those are the molar ratios. We can find them out by balancing a reaction. You see the coefficients over here. So here we have 6, 1, 6. So these we normally find out. We don't have to do a particular reaction or an experiment to find out the molarity or the number of moles, not the molarity, number of moles. Molar ratio, we can find them out by balancing the reaction. But to find out the orders M, N and P, we have to perform a reaction. So that is a reaction that we perform and then try to find out the orders of the reactions. And there is a data sheet posted on Blackboard that you have data obtained from this reaction. I'm going to go ahead and write down these orders again here. You will see in the data section for the first reaction mixture, when you mix those ingredients together, time to for the color to change, time it take for color to change 141 seconds. So for the second one 69, third one 76, 35 and the last one 161, but we're not going to worry about the last one. You don't have to worry about that. Okay, let's only focus on 1 to 4. Now the rate is proportional to the time. So for that, in order to put it into use, we're going to use the relative rate of the reaction as 1000 over time it takes. So 1000 over 141. So do these calculations yourself, because I might do something wrong. So you want to find out that if I have done any mistake, and you need to do the correct calculations. So the first one would be 1000 over 141. So you might get a number like 0.7092. Again, check to see if these numbers are correct. So the second one would be 1000 over 69. You will get something like 14.49. And then the third one, 13.58. 1000 over 76. 1000 over 35, 28.57. And you also need to complete the table that is given here, and I explained you how to do that in the pre-lab calculations. Also it is given here because we want to find out the concentration of each reagent in our final reaction mixture. We know for each one what is the molarity of the stock solution. For example, we are given the calculation for iodide concentration. We can use the dilution equation M1V1 equals M2V2. So the number of moles, yes, V1, M1V1 equals M2V2. Iodide stock into volume stock equals iodide mixture into volume in the mixture. So the concentration of iodide in the stock solution 0.01, and then the volume we took was 10, and then the total volume is 50. So all our 1 to 4 reaction mixtures, the volume going to be 50. Okay, so with that in mind, we can find out what's the concentration of iodide in that reaction mixture when the two flasks mix together. So that 0.002. Excuse me. So likewise, you can find out the concentrations of bromate H and H plus in 1, 2, 3, 4, 4 of these mixtures. So you refer to the table given here. For example, for the iodide is going to be 10 in the first one, so the second one would be 20. So the concentration would be doubled, and for the third and the fourth, concentrations are going to be the same, right? For iodide. So this is also going to be 0.0020, and this also would be 0.0020 because it's the same volume. It took 10 milliliters, but for the second one it was 20. So then we can expect that it to be doubled, 0.0400. Let me erase that. 0.0040. So likewise, using the dilution equation, you can find out the bromate and H plus ion concentrations too. I'm going to go ahead and write down those numbers, but make sure that you do it yourself. I am trying to do some mistakes since you guys are not in front of me to ask if I'm doing it correct. So make sure that you take charge and to see if I have done any mistakes, and feel free to send me an email letting me know about it also, so then I can let the other students know about it. Okay, so likewise you find H plus concentration 0.020. Again, this is very easy calculations, but I want you guys to do it yourself. Do not depend on my work, okay, because you need to learn. Okay, 0.02, and the last one, we double the hydrochloric acid concentration. It would be 0.04. And then the temperature for these reactions measured is also given. Okay, so you can refer to that data from the data sheet. Okay, now that you have this information, we're going to use this to find out the orders of the reactions. What is the order with respect to iodide and bromate and H plus? How are we going to do that? Okay, so here, so you see, now we're gonna divide. You may have already learned this information in your lecture also, because it's the same thing that we are learning in the lecture. So you take two relative rates where you have kept two of the reagent concentrations the same, but you made one of the reagents concentration change. Okay, so relative rate 1 and 2. So if you look at relative rate 1 and 2, 1 and 2, look at here 1 and 2, we have iodide, bromate, H plus. We're going to take this relative rate and this information and we're going to divide one by another one. Let's say you divide 1 by 2. Okay, which ones are going to be the same concentrations from iodide, bromate and H plus? Bromate and H plus has the same concentration, iodide is different, right? 0.002 and 0.004. So when you do divide these by each other, we should be able to find out the order with respect to iodide. What about 1 and 3? If you divide 1 and 3, 1 by 3, which concentration, or the not the concentration, which order are you going to find out? Iodide 002, 002, the same. And then bromate 008 in reaction mixture 1 and 3.016. And H plus 1 and 3, they are the same. So when you use 1 and 3, you divide one by the other one, we should be able to find out the order with respect to bromate. So likewise, which two reactions do you think we can use to find the order with respect to H plus? Which one? Which two do you think we should be using? We can use 1 and 4, right? Because in 1, iodide and bromate, they are the same concentrations, whereas H plus, it's different, right? So that is what we are going to do. We're going to divide one relative rate equation with another one. Okay, let's say relative rate 1. Now we found the relative rate 1 as 7.092. So you're going to go ahead and write down that information. Okay, that's going to be 7.092. You can go ahead and write it down. 7.012. That's the relative rate. That's the number we got, 1000 divided by 141. And then the K prime is the rate constant. And then the concentration, iodide, bromate, H plus. Those are the orders for M, N and P. So the first one, iodide concentration is 0.002. So the second one, the bromate concentration, 008. And then the third one, H plus 0.02. You take this information from the table where you have the reaction 1. And then the reaction 2, relative rate 2, it is 14.49 from your table. And then concentration of iodide 0.004, 008 and 0.2 for H plus. Now you're going to divide this together. Rate 1 over rate 2. So 7.012 you divide by 14.49. What would you get? Can you do your calculations in your cell phone or your calculator and tell me? 7.092. 7.092. What did I write? 7.092. Yeah, this is 9, not 1. 7.092 over 14.49. What's the answer? 0.4 something? Okay, so we can round it up to 0.5, right? You divide that. And then also you're going to divide these two. So when you divide that part, numerator by the denominator, this is the same, you can cancel. This is the same, you can cancel 008. And then you're going to divide 002 by 0.004. What would you get? 0.5, correct? And then this one, since they both are M, that's going to be your order M. So what's going to be the value for M? What is the value for M? 0.5. When you raise to which power will you get 0.5? M would be 0? No. 2? No. It's 1. Right? M would be 1. So you found the order of the reaction with respect to iodide as 1. Now we need to do the same thing to find out the order for bromate. So for that we're going to use relative rate 1 and 3. Relative rate 1 information, this one and 3. So you're going to divide 7.092 and by 13.58, and then also you're going to be using these concentration values. Okay, we're going to put that information here. I don't have to do the rest. You guys basically know what's happening now, right? So relative rate 1, 7.092. And then the relative rate 3, 13.58. And then you're going to write down the concentration terms for reaction 1 and 3. 002, and then you have 008, then you have 0.02. This is the same 002. This would be 0.016 and 0.02. Now you're going to divide one equation by the other one. You can either do relative rate 1 over 3 or you can do 3 over 1. I'm going to do 3 over 1 so I get whole numbers instead of decimals. You can do the other way around too, but it doesn't matter. You'll get the same answer. So 3 over 1, 13.58 over 7.092. What is the number you're going to get? That would be 1.91. 1.9. 1.9 is pretty close to when you make it whole number. 1.9 would be 2, right? And then you are dividing 3 over 1. When you divide 3 over 1, so we have 002, 002 will get cancelled. 02, will get cancelled. And then we have 0.016 over 0.008. They both have the same exponent n. 16 over 0.008 gives you 2, correct? So what you're going to have is 2 equals 2 raised to the power n. So then what should be the n going to be? 2 raised to which power will you get 2? That would be 1. So n equals 1. Right? Anything raised to the power 1 is the same number, correct? And anything raised to the power 0 would be 0. Right? So we found the order with respect to bromate too. Now the last one is we're going to find out the relative rate. From the relative rate we're going to find out what is the order with respect to H plus. So you can use a relative rate 4 for that. Okay. So you can go ahead and write down the information for the 4 and then you can use relative rate 1 and you can use relative rate 4 to find out what is the order with respect to H plus. Okay, rate 4 by rate 1. You can do rate 1 by rate 4 or rate 4 by rate 1. So relative rate 4 is 28.57. We can do 4 over 1. I mean, you don't have to follow me. Now you know what to do. So you can go ahead and try yourself. It's going to be 28.57 over 1, 7.092. And then you put the informations for relative rate 4. Okay, so in the relative rate 4, you will see when you divide 4 by 1, here 4 over 1, which are the ones that's going to cancel? So if you divide 4 by 1, so here we have 0.002, 002 iodide, they are the same. And bromate 008, 008. And for the hydrogen, H plus 0.04 over 0.02. Right, that's what going to be remaining. And remember, we cancel the k prime for each of these cases. K prime is a rate constant because the rate constant only depend on the temperature. If you are running all these reactions in the same temperature, so we can assume at each time the k prime or the rate constants are the same. So that's why when you do divide these equations, we cancel k prime also. Okay, now for the last one, for over 128.57 over 7.092, and for the H plus it was 0.04 over 0.2, and this is the P order with respect to H plus. Okay, that would be 4 equals 2 to the power P. So what is going to be P? 2 raised to the power P equals 4. What should be the number for P? That would be 2, right? 2 times 2 is 4. So P would be 2. In case if you don't see what is P right away, you can use this formula. If you have a number A equals B raised to the power, let's say n, you can find out n equals log A over log B. If you don't see how the 2 comes, you can use this. Log A is 4. Log 4 over log 2 will give you 2. Okay. Now we know the orders with respect to H plus, bromate and iodide, 1, 1 and 2. Now we can use these orders and the concentrations and the relative rate to find out the rate constant for each of these reactions. Though we know that they need to be similar, but we don't know exactly what that number is. So you're going to be using these orders to find out the rate constant, which is going to be K prime. Having found M, N and P, nearest integers, the relative rate constant K prime can be calculated by substitution of M, N and P and the known rates and the reactant concentrations into equation 5. Evaluate K prime for reaction mixtures 1 to 4. So you only need to do it for 1 to 4. I'm going to go ahead and erase this part. And let's say our equation 5 is, where's the equation 5? Is this one right here. Relative rate equals K prime iodide, the order, BrO3, bromate, order, and H plus. Now that we know the orders, we also know the concentrations for the reaction 1, also know the relative rate. We can plug these numbers and the orders to that equation 5 and can find out the relative rate. I will show you how to do that for the first one, but for the second, third and fourth reactions, you guys can do it together. I mean, you can do it yourself and you can find out the average at the end. So let's do that. I'm going to write it down here. So the relative rate for the first one, and it was 7.092, right? So the relative rate for the first one, that was 7. I'm using equation 5. So the relative equation 5 for the first reaction, relative rate is 7.092, and we don't know the K prime. That's what you're going to find out. And for the first one, iodide concentration 0.002, and you guys found out the order, which is 1. And then the bromate concentration 0.002, bromate 008. See, I did a mistake. You guys didn't even tell me. 008. So that's supposed to be 0.008. And then the order we found as 1. And for the H plus, that's going to be 0.02. And then the order is 2. Now we know everything except K prime. So when you solve, so you take 7.092 and you divide it by 002, 008 and 0.02 raised to the power 2. When you do that, you might get an answer, a huge number. It's a high, very high rate constant. You will get something like that. 1.1 into 10 to the 9, something like that. That's going to be the rate constant. And you're going to go ahead and do your own calculations for the second, third, and fourth. Again, for the second one, your relative rate going to be 14.49, and then the iodide concentration would be 0.002, bromate 0.008. No, for the relative rate 2, iodide would be 0.004. See, I told you to look it up. 0.004, bromate 0.008, H plus 0.02. So you find what is the K prime. So you do it for the second, third, and fourth, and then find the average. You know how to find the average. You add them all together and then divide by 4. Okay, and then it is asking, why should K prime have nearly the same value for each of the above reactions? So what do you think? Well, you will find all of these have at least the same exponents. It may not necessarily be 1.1 into 10 to the 9, but 10 to the 9 part would be the same, but the other number can be changed. Okay, so what is the reason why they have about the similar values? Because all of the reactions we performed in the same temperature. Only the rate constant changes if you change the temperature. Okay. Using K prime average in equation 5, predict the relative rate and time for reaction mixture 5. Okay, don't worry about that. We're not gonna go ahead and do that. So when you do this K prime average, you are done. So don't worry about this part. We're not going to be working on that. And also, we're not going to be doing the effect of temperature on the reaction rate. Okay, so don't worry about that part either. So you only need to complete this part and turn it in. Okay, I hope you understood, and if you do have any questions, let me know. Okay, all right then, bye for now.